guys, welcome back to my channel. Today we'll do acids and bases. I'll split this video into two parts. Obviously, we'll start with the homework from my last video. So the question was whether zinc will react with copper sulfate solution or not. Now, this is how the reaction will proceed. So the zinc replaces, there is a displacement reaction, replaces the copper sulfate and becomes zinc sulfate, and copper becomes a solid. So that was the first part to complete the reaction. B was to write the half equations. Now, so zinc is 2+, which means it has to lose 2 electrons. And the same is with copper. It's copper plus 2, so it loses 2 electrons as well. Now, I gave you the electrode potential for both of them. The part C was to state whether it is a positive or negative electrode potential and whether it will be spontaneous or not. So EMF was the standard potential of the reduced minus the potential of the oxidized. So from this reaction, we can say that zinc goes from 0 to +2, which means it has been oxidized, and copper goes from +2 to 0, which means it has been reduced. So we write 0.34 first because copper is reduced, and 0.76 because zinc is oxidized, and we get 1.10, which is positive number, so we can say that the reaction is spontaneous. The second question was you had to balance the equation. I always told you start with the oxygen. So we have 4 oxygen on the reactant side and only 2 on the opposite side. So if I add 2 to the oxygen on this side, it will also alter the number of carbons, and the carbons on the reaction side is only 1. So it's going to change the whole oxygen number. So let's try 3 instead. So we can see that if I put 3 there, the oxygen becomes 6 and the carbon becomes 3 on each side. So the carbon's done, but then the oxygen becomes 6, and on the reaction side you have 3 oxygens and another 3 oxygens, so that also becomes equal, 6 and 6. So now our only worry is the ion. So we have 2 on the reaction side. So if we put a 2 in front of the reaction side, the product side, sorry, everything is balanced. Then second part was which of the elements has been oxidized. So let's write the oxidation states of everything. Iron is +3, oxygen will be -6, here -2, carbon +2, iron will be 0 in its natural form, oxygen -4, and carbon +4. Okay, so which one has been oxidized? You can see that carbon has gone from +2 to +4, so carbon has been oxidized. Number C, which one has been reduced? We can see that iron has gone from +3 to 0, so it has been reduced. For which element has been oxidized or reduced, you have to only write the element, okay, not the whole compound. D was which was the oxidizing agent. For agent, you have to write the full compound. Because carbon has been oxidized, so the oxidizing agent will be the other compound, which is the iron oxide. And because iron has been reduced, the reducing agent will be the other compound, which is the carbon monoxide. Okay, now starting with today's lesson, in general, what are acids? What do they taste like? So acids are sour, and we know that on the pH scale, they are less than 7. Bases are bitter, and on the pH scale, they're more than 7. So the neutral pH is pH equal to 7. So below that is acid, above that is base. There are 3 theories about acids and bases. So the first one is Arrhenius, the second one is Bronsted-Lowry, and the third one is Lewis. So Arrhenius says that when you ionize a compound, if it releases hydrogen, it is an acid. If it releases hydroxide ion, it is a base. For example, I'll take HCl, and if you ionize it, you will get H plus and Cl minus. So according to Arrhenius, HCl is an acid because it released H plus ions. Bronsted-Lowry, they are to do with proton donors. They're to do with protons. So proton is hydrogen ion. So if a substance is to be an acid, it has to donate a proton. So acids are proton donors and bases are proton acceptors. For example, I'll take acetic acid and reacted with water. Now the compound will be acetic ion and a hydronium ion. So here we can see that the acetic acid has donated a hydrogen or a proton to the water. So acetic acid will be the acid in this case, and water will be the base because it accepted the proton. And on the other side, the product side of the reaction, we can say that the acetic ion is the conjugate base of the acetic acid, and these are known as conjugate acid-base pairs. And the water will be the conjugate acid of the hydronium ion, will be the conjugate acid of the base, which is the water. Now, the stronger the acid, the weaker its conjugate base, and vice versa. Then we can go on to the Lewis, which says it's to do with electrons. So they say that acids are electron acceptors, which is the opposite of what Bronsted-Lowry said, but in terms of electrons. And electron donators are bases. So for example, we take ammonia and we will react it with water. So we see that ammonia, nitrogen, has a lone pair of electrons, and it donates these electrons to the water. So the base here will be ammonia because it's the electron donor, and water will be the acid. And then you have the conjugate acid, which is the ammonium ion, and the conjugate base, which is the hydroxide ion. Alright, now there are some things that you need to know, some terms. So first is autoionization of water. What does it mean, autoionization? That water will ionize itself. So water plus water will give you hydronium ion plus hydroxide ion. So when you are asked in the exam, show the reaction of autoionization of water. This is what you need to write. The second one is ion product of water. So using this reaction, you have to find the equilibrium constant, which is Kc is equal to the products over the reactants. Now you will shift the water to the Kc side, and the water then becomes K, the constant then becomes Kw, the constant of water. Why? Because water in itself is constant. So Kw is equal to the hydronium ion, or H plus, times the hydroxide ion, and this is your ion product of water. Now we'll move on to pH. So how to find pH? pH is equal to minus logarithm of the concentration of hydrogen in the solution. pOH is minus logarithm of the concentration of hydroxide ion in the solution. What is pKw? It is the minus logarithm of Kw. So pKw is equal to pH plus pOH. Now pKw in under standard conditions is 14, and then under standard conditions pH and pOH will be equal, so it will be 7 plus 7. I will do some questions with you. So our first question, for example, will be find pH if the concentration of hydrogen is 0.1. So pH is equal to minus logarithm of 0.1, or 10 to the power minus 1, which is equal to pH being 1. You can also be asked a question, for example, find pH if pOH is 4. So we know that pKw is equal to pH plus pOH. pKw is 14, pH we need to find out, and pOH is 4. So doing algebra, you're going to find that pH is going to be 14 minus 4, which is 10. In the laboratory, there are various ways to find the pH of a solution. You can use pH scales or meters. The most commonly used one is indicators in the laboratories. So you know about litmus paper, phenolphthalein in my previous videos, but I want to show you the reaction that happens. So we have the reaction HLN plus water, which is ionization. Indicator becomes the base. Now, this base, the conjugate base, is what gives the color, the change in the color of the solution. And then the last part is amphoteric compounds. Now, what is the meaning? Amphoteric is when a solution or when a compound can act as an acid and a base both. When this occurs in amino acids, because amino acids have an amine group, which is basic, and a carboxylic group, which is acidic, so it can act as an amphoteric compound, but the term for amino acids is zwitterion. So, for example, you have hydrogen carbonate. If you add a hydrogen to this, it can become an acid, and if you remove a hydrogen from this, it can become base. So it is amphoteric. Why? Because if proton is donated to it, it will become carbonic acid, and if proton is taken away from it, it becomes carbonate ion. So it can act as both an acid donor and an proton donor and a proton acceptor. Okay, so the homework for today, the first question will be find concentration of OH minus if the concentration of the hydrogen is 10 to the power minus 1 or 0.1. Question 2 is find pH if the concentration of the hydrogen is 10 to the power minus 7. Question 3 is which of the following is a Bronsted-Lowry acid? Is it A? Is it B? Is it C? Is it D? Question 4 is which of the following is amphoteric? Is it A, B, or C? And that would be it for this video. See you in my next one. Bye.